Good day. Hello, ladies and gentlemen. Welcome to our Connection Wednesdays webinar series. Today is the 3rd of March, and we're going to look at a topic about our BIM link with ETABS. So let me jump to next slide and introduce ourselves. My name is Adam, and here's my colleague Alex with me today.
Hello, everybody.
So we're greeting you. We are both product engineers with IDEA StatiCa, and we deal with application connection and other steel applications that we provide within our software package. So to all of you that are new to the GoToWebinar platform, you are all muted by default as attendees, but please feel free to ask any questions in the question panel that you have of your GoToWebinar application. Just click there and type your questions or suggestions, and we'll try to answer them at the end of this webinar or later on by email. So for today's agenda, this is quite straightforward. First, Alex is going to show you how the up-to-date BIM link with ETABS and IDEA StatiCa connection works, how it looks like, and I'll give you some tips for the workflows. And then at the end, I'll quickly make some comments about friction, the physical phenomenon of friction between plates in our CBFEM model, in the numerical model that IDEA StatiCa uses. Okay, so that's it for today, and I'm giving presenter to Alexander now. And so Alex, the floor is yours, and go on.
So thank you, Adam, and welcome once more. And just for the beginning, what you can now see is our internet page, ideastatica.com. And if you are interested in any BIM links for IDEA StatiCa, just go to our website and use the tab BIM links, and you will get a lot of information about the BIM links and all the features we have connected to these BIM links. Today we will talk about the BIM link with ETABS. Our BIM links are based on our application code check manager, and I will show you how to export a single joint or a bulk export of the joints, about the loads, about the synchronizing the models. It means we can synchronize any changes you are doing in ETABS. That means if you are going to make changes in IDEA StatiCa, it's not possible to put it into the ETABS. That means we have only one way link from ETABS to IDEA StatiCa. And the last thing what I will show you is to export the designed joint into our next application viewer and to export to DWG file. Our BIM links are based on our open IOM model. If you want to know more about it, again, you can find more information on our website. Right now, the latest version of IDEA StatiCa supports the version 18, 17, 18, and 19. So if you have older versions, please upgrade your version to the latest one to guarantee all the features we have. So and now we can start our sample project. First, what you have to do if we are starting IDEA StatiCa, normally you go to the tab BIM and click on the activate your BIM link. You can see here for ETABS 17, 18, and 19, you are not able to make the link directly here, but you have to do it in the application ETABS itself. So if you are clicking on this link, you will be linked to our website where you get more information about. So it's not necessary in this case. So I will close it again and go directly to ETABS 19. So well, here I will open a project, a simple one, just dead load and one live load. You can download this file also on our internet site. First, what you have to do is to integrate the IDEA StatiCa. So you go to Tools and click on Add Show Plugins. Here you select the button Browse, and here you have to go to the this PC and to the program files. You can find the IDEA StatiCa folder, IDEA StatiCa 20.1, and here is the DLL file ETABS 18 plugin IDEA StatiCa. It works also right now for the version 19. So I click on Open and click Add, and you can see it was integrated. The status is okay, so we can continue with our export of the joints. So first, I go again on the tools, click on the My ETABS, and window with our CodeCheck Manager appears. Here, if it's a new project, you can select your code. Now we will work with the American code, so I will click on this icon and click Continue. And right now we can make the selection of the joints. You have the possibility to select one joint, or you can select also a bulk, several joints together, for example, this one and the second one, and click again on the CodeCheck Manager and click here on Connections. And now you can see we have imported point number 1 and point number 2. Here in the table on the right side, you have the possibility to change a little bit something. For example, here we have the column 4 and 9, and we can expect that this column is a 1 member. So I can click on the number 9 and say, and click on the button merge, and we get one member. And of course, we also can select this member as a bearing one. It has no influence on the computation, on the analysis, but it's not bad to have it as this as a bearing one. The next one, we can also do it in 1. Here is the same, number 10, we will merge together with the number 5 and make it as a bearing. And the next thing, I can click on finish. Number 2 also on finish, and maybe I will select the number 2. In this case, after finish, this will change. You get the button open, reset, and rename. So you can rename the joint. You can, of course, if you select the incorrect column as to merge, you can say member 1 and number 2 has to be merged. So you can click on reset, and again you get the picture as here. So this possibility is here. So but I make again finish and click on open. So here we get the joint imported into IDEA StatiCa, but what we do not have are the load effects. The load effects are not here because it was my choice. I didn't make the analysis of the ETABS. So right now we can close it, move it and go back to ETABS and click on Analyze. So it looks like they going through it, through the analysis. And here right now, we can do one more thing. We have here a button, synchronize all. And it means that after that, all the missing loads from ETABS will be imported into our joints we previously imported into IDEA StatiCa. So it went through, and I will click again on open. And you can see we have already the items here. So in this case, we used the synchronizing button to upload the correct loads. And of course, you can do it also with the members. If you have, for example, if you change the height of the member, again, go to ETABS, change it there, make the analysis again, and go back, click on the button synchronize, and the changes will be imported into IDEA StatiCa. So the next thing what we have to do, you have to apply the operations. You have the possibility to click on the button operations, and you can choose the operations from this table, but we will do it in an easier way right now. I will click on the right click button on the member number 1, and here select connect to and select the column. And from this table, you can select any possible connections you want to have. For example, this one. Okay, I will click on here, and you can see we got ready made operation on our joint. But it's not 100% correct. So we will here change it a little bit, and here we will change it for the number 2, and you can see we got also on the other side the backing plate. And it's not all. We want the widener also on the second side, so we'll click on copy and say it's not on the member 1 but on the member 2. So that was very easy one, and we can make the calculation. So you can see we are more in green colors, so it looks good, very good. You can go to the tab check and see more about the plastic strength, for example, equivalent stress, deformation, and so on. And we can also look at the tables, what we get, how the results looks like. For example, here in the boards, here is the button plus, and if you click on with the right mouse on the field, you can look at you can see the print preview, and here are all the information, how it was calculated and how the results looks like. And if you go to the tab report, you have several possibilities. You can look at you can get a brief report, one-page report, or detailed. And here in the detailed, you again can select more information. Then click on refresh. And all the formulas and pictures you would like to see in the report will be here placed in here. And this can be downloaded as Word or docs file or PDF file, and you have also possibility to select the bill of material. It's something like more information for the detailers here. So I go back to design, click on save, and if I with IDEA StatiCa, the code check manager is still here, and on the right side you can see how the joint looks like, and also you get the results here in this small table. Maybe for those who want to get more information about the joint itself, we have since the version 20.1, we have here the possibility to calculate the costs for the joint. So we have here, you can here select how much does it cost, for example, steel parts, fillets welds, butt welds, hole drilling, and so on. And in the case you would like to see it, you can check or uncheck these costs. If I uncheck it, then there's no results here, but in the IDEA StatiCa, but if you check it, you can get also the how much the joint will cost you. So for those who want to show the finished joint to some colleagues, and the colleagues do not have IDEA StatiCa, we have the possibility to export it using our next module, and the module is called Viewer. So if you go to our web page, here on the button on the left side is the button Viewer, and here you can select the joint you have designed. The joint, the file with the joint, where it is stored. As you could see at the beginning, the ETABS file was stored on the desktop under the file number 1. And here, when you are starting a new project, the new folder will be created. The folder will be created with the name of the ETABS project, and at the beginning there will be placed IDEA StatiCa. So I go here to this folder and his subfolder connections, and it was, I think, joint number connection 1. Oh, it was not the 1, sorry, it was the connection number 2, so sorry. And here, oh, it was, I'm not sure that it's now, it has to be to open. No, not sure how it's look like. Okay. So this one, I'm sorry, I placed it somewhere else. So you can see here we have the design joint here. You can see, and the next thing what you can do, you can export it to the AutoCAD file. So here you can click on this icon, and I have our application connected to advanced steel. So it will be loaded into advanced steel. Takes a little while. So, and you can see it doesn't look 100% as it was in the IDEA StatiCa file. It depends on the way how the advanced steel is loading our file. So in this case, you can use the command audit, yes, and it will be corrected. So you can see right now it looks exactly as it was in IDEA StatiCa. So that was all from my side about the BIMlink, ETABS, and IDEA StatiCa, and I will pass the presentation to Adam again. So.
Okay, I take it. So you should be able to see my continuing part of the presentation, which is actually just this one slide before I jump into the application connection as well. So I want to make some comments about friction between plates in our numerical model in IDEA StatiCa connection. So I'll jump into the application, and I have summoned just this simple model which consists of a column and a beam connected to the column by this, if we can call it a clip or something, basically two plates connected by preloaded bolts. This means these bolts are set to the shear force transfer by friction. So you can imagine this kind of connection. This is pulled together, and by friction between these two plates and these two plates in here, the whole connection is tightened and stays in place, right? So we understand how this works in reality with physics, but this is a different thing. This is a numerical model, a finite element model, and in such there is actually no friction between the plates, right? So the friction doesn't work at all. We can see when I'm going to calculate this now, what's going to happen. I have this beam loaded, or there are nodal internal forces in the node. From the beam, there is a normal force, shear force, and a bending moment. So if I calculate this now, you'll see the analysis wasn't performed, 0% load was applied, and I don't get any results. This is because there is no friction between the plates, and that means this doesn't hold the position, and this numerical model basically falls apart. Right, so if you are interested in finding more information, you can go to our webpage, go to support center, and just type friction. Here you can filter, you're focused on steel, and you can take the knowledge base articles or the help articles, and you can read about preloaded bolts, or why the analysis didn't reach 100%, why it wasn't performed, and how does it work with friction. A friction in IDEA StatiCa connection model works only between concrete base plate, between the concrete block and the steel base plate, in terms of you're modeling a footing. But there is no friction between the plates. So how can we deal with that? There is a workaround for this. So the problem is this is falling apart, so we have to stabilize it. I can do this by adding a single weld operation, and I will connect this plate, its edge number 2, it's the upper one, and the top flange of the column. And here I can set the weld as a very small one, and I can even set it as a partial weld, something like this. And this is going to serve only as a, let's call it utility weld, only to stabilize hold this in position. So this might help in some scenarios, and you have to be really aware of what you're doing, because, for example, in this scenario, what I have just done is now I have calculated the joint. Everything seems okay. When I go through the plastic strain display, I can turn on the mesh and deform shape. I can see there is something happening. This is all like tilting away. When I turn on the stress, I can see this actually, the whole connection is held by just this small weld, right? So I have contact between these plates that works in pressure only, but I wouldn't call this model a correct one. So if you're interested in finding out some, let's say, behavior or some results regarding maybe the bolts or something, this is usable, but I wouldn't say this is 100% correct, right? But still you can get some information. But let's see if I make a copy of this one. Let's see about the same connection where we can say this is correct, where we can say we are safe. So let's imagine this is not a column, but a roof beam, for example, and this is some member that's hanging on the beam. So this is kind of hanging support or hanging connection. So this means I will have different forces. Let's say I have 100 force of tension, and I have this very same scenario. I have the friction bolts, I have the contacts. I can show you how this looks like by using the grid, the bolt grid operation. You can switch to contact here, and this is the red square between the two plates on the connecting area. The same contact is on the upper part, and of course I have this stabilizing weld. If I turn it off right now and leave it like this and try to calculate, I'm getting interesting result. That means no result at all. Why is this happening? Since I have only the normal force, and I would assume this is really calculable. This is because by inducing the tension force to this connection, the connection is being deformed, and by the small deformations, there are very small shear forces and small moments generated as a prying forces. And this means, again, the connection is will fall apart. So I really need to add this utility weld, because again, there is no friction between the plates. And then right now I can see I have calculated the connection, and if I turn on again the strain and the shape, and this is overscaled too much, let's say like this, you can see these deformations I was talking about. There is some weld failing the code check. This is overloaded, but overall this is working well. If I turn on the stress, I can see the stress flow on the contact of the plates, of course. So in this case, this utility weld provides me only the stability of the overall model, but doesn't take any load, doesn't transfer any shear load between the plate and the beam. So this is the correct way where we can use this. even when there is no friction in the numerical model between the plates, right? The contact works in pressure only. So that's a conclusion of the tip. This is quite often question on our help desk, and I will come back to presentation and we can conclude this webinar. But before we do that, we can take a look at some questions and answers. So let me take a look, and I will probably have a question for Alex about ETABS. Carlos is asking about eccentricities. If I have eccentricity in ETABS on a beam, is it imported or how does it work?
Yes, thank you, madam. With the eccentricities, it's a little bit strange. IDEA StatiCa is not able to import it. It means the position of the beams. The load effects are imported correctly, but the beams are imported as if there would be no eccentricities. And we have some more information about it on our web pages. It is named known limitations for ETABS. And it is so that the correct way in ETABS looks like this blue picture, but you get the incorrect position of the diagonals. So it means you have to either move the diagonals to the upper point, to the green point, or the green point to move from the horizontal beam to the center of the diagonals. Yeah. So there's no other changes. The loads effects are imported correctly, but all you have to move the beams. Maybe another question here from other visitor, how it is with the if we have joints which are several times in the same construction and they look in the same way. So it means that you have, for example, this same joint, for example, 10 times in your construction. What you can do is to use these operations which you have designed, and you can do one thing. You can take this possibility to create a template. You can call it what I mean, for example, 45, it doesn't matter. And then if you here, for example, if I clear the operations, I can here use the button apply and my joints, and it is here stored. Very important information. If there is no picture you can apply, that means that your joints doesn't have the same geometry. It means, for example, the beam number 1 has a declination of 1 degree, and the original has, for example, 2 degrees. In this case, you would not be able to apply the geometry and the operations on the other joints. The geometry must be the same. The beams can be different. For example, the height can be 200 and the new one that can be 300. It will appear here, the template, but the geometry must be the same. So Adam, do you have any other questions or?
That's it. We have also answered rest of them during the webinar, and if there are any following, we'll answer them by email. So I'll take the presenter back and I can conclude today's session. So just short info at the end. After the webinar, you will be asked to fill a short survey. The recording of today's session will be available till tomorrow in our YouTube channel or on our webpage in webinars section. Of course, you can feel free to download and install our free trial with full functionality, where you can test the ETABS BIM link as well, of course. And feel free to browse our, of course, free support center, where you can find more information about the software and so on. And about next webinars, what's in front of us, 3rd of March. That's probably a mistake. There should be a 31st of March because 3rd of March is today, right? So in a month, there'll be another Connection Wednesdays webinar about Hung Expo project, Arrival Hall. That's a new project in Hungary. A very interesting spatial steel hall where IDEA StatiCa was used to optimize and tune in the 3D steel frame of the structure and its connections, of course. And then in the end of April, there will be new version of IDEA StatiCa 21, and it will be the release webinar about what is new in this new version. So that's it. And the very last thing, to those that are interested in getting skilled in using IDEA StatiCa connection and generally in connection design of steel joints, you can check our campus program. You can get a certified professional. This is a online course that takes about 40 hours. And here you can learn not only the basics, but the very advanced features of the software and the overall information about connection design. So that's IDEA StatiCa Campus. And what's left is just to thank you for attending today's webinar. We're glad to see you here, and we're looking forward to meet you next time. So have a nice rest of the day, and bye-bye.
Goodbye.